Hi everybody, welcome to your last Algebra 2 test review video. This is for Unit 6.3 over trigonometry and angles. Let's go ahead and get started. On number 1, they're asking us to find the values of six trigonomic functions for theta. Well, remember that theta is our angle, and they've given us the three sides of the triangle. So we can go ahead and label the side across from our theta as our opposite side. The side opposite or across from our right angle, our hypotenuse, and the side that's next to our theta but not our hypotenuse as our adjacent side. Okay, so now let's go ahead and keep going. Now we've labeled our sides. Well, we look over here at our notes that you should have written down, the SOHCAHTOA notes, and sine of theta is the opposite over hypotenuse. Well, that in this case is 9 over 41. Cosine is adjacent over hypotenuse, so that's 40 over 41. And then tangent is opposite over adjacent, so that's 9 over 41. Oh, I'm sorry, 9 over 40. Alright, cosecant is the opposite or flip of sine, so instead of it being opposite over hypotenuse, it's going to be hypotenuse over opposite. Secant is the flipped version of cosine, so instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And then cotangent is the flipped of tangent, and that's opposite over adjacent. Oh, adjacent over opposite, which is 40 over 9. Okay, on problem 2, they've given us two sides of our right triangle, and we have to find the third. And the way we're going to do that is use the Pythagorean theorem. So we're going to have a squared plus b squared equals c squared. And we know that c has to be the side opposite of our right angle. So a and b can be the other two sides that they've given us. So we can do 2 squared plus the square root of 5 squared equals c squared. So that becomes 4 plus the square root of 5 squared is just 5 equals c squared. So 9 equals c squared, and when you take the square root of both sides, you get c is equal to 3, because that is the square root of 9. So now we have all three sides. Let's go ahead and label which side's which. Well, since this side is opposite our right angle, or across from our right angle, that's our hypotenuse. The side opposite of our theta is our opposite side. And the side next to our theta, but that's not our hypotenuse, is always our adjacent. So, let's go ahead and get started on what these things mean. Our sine is always opposite of our hypotenuse, so that's going to go ahead and be, that will be 2, opposite, square root of 5 over 3. Well, that can be our sine. And since cosecant is the flipped version of that, that's 3 over the square root of 5. Well, we don't like having a radical on the bottom, so we multiply the top and the bottom by square root of 5. And when we do that, we end up with 3 times the square root of 5 on top, and then just 5 on the bottom. So our cosine is 3 times the square root of 5 over 5. Alright, now let's move on to cosine. Cosine is adjacent over hypotenuse, so that's 2 over 3. And our secant is going to be 3 over 2, because you flip the cosine for your secant. Okay, now for tangent, it's opposite over adjacent, so that's the square root of 5 over 2. And since cotangent is the flipped version of tangent, that's 2 over the square root of 5. But we don't like having a radical on the bottom, so we have to multiply the top and the bottom by the square root of 5. And when we do that, we end up with 2 times the square root of 5 on the top, and the square root of 5 times the square root of 5 is just 5. Alrighty, let's move on to problem 3. In this case, they've given us an angle of 45, and that becomes our theta. So we can label 45 as our theta. And they've given us the side opposite from our theta, so that's the side opposite. And this x, the side that they want us to find, is our hypotenuse, since it's across from our right angle. So, x is going to be, since they've given us our opposite and hypotenuse, we're going to write sine of theta equals opposite over hypotenuse. Now let's fill in what we know. Well, sine of theta in this case is 45. Our opposite side is 5, and our hypotenuse is x. Well, we know, based on our unit circle, that sine of 45 is the square root of 2 over 2. And that's equal to 5 over x. Now we can cross multiply, and that leaves me with x times the square root of 2 equal to 10. Then I divide both sides by the square root of 2 to get x by itself. So x equals 10 over the square root of 2. But we do not like having a radical on the bottom, so we have to multiply the top and the bottom by the square root of 2. And you're left with 10 times the square root of 2 over 2. Because square root of 2 times square root of 2 is the square root of 4, which is 2. So when we reduce 10 over 2 to be 1 over 5, you're left with x being 5 times the square root of 2. Okay, now moving on to this side, they've given us 30 as our theta. The side opposite from our theta is x, and the side next to our theta that's not our hypotenuse is our adjacent side. So, we know because the adjacent side is not across from the hypotenuse, that is why. This side is our hypotenuse, so make sure you're not mixing up those two things. So, they've given us our opposite and adjacent, so I'm going to use tangent, because tangent of theta equals opposite over adjacent. So tan of 30 equals x over 7. So then I multiply both sides by 7. So 7 times tangent of 30, which we know is the square root of 3 over 3, equals x. And remember, I found what tangent of 30 is by looking at my unit circle. So x equals 7 times the square root of 3 over 3. Number 5 tells us a biologist's eye level is 5.5 feet above the ground. She measures the angle of the elevation to an eagle's nest on a cliff to be 66 degrees when she stands 50 feet from the cliff's base. To the nearest foot, what is the height of the eagle's nest? So we have our little biologist. Let's go ahead and draw her. And we know that her eye level, okay, is going to be 5.5 feet off the ground. Well, that's also this cliff over here is going to be 5.5 feet off the ground according to our eye level. And then there's an eagle's nest up at the top of the cliff. So we can draw our little picture with our eggs and our eagle's nest. You can be as artistic as you want, but it will help you if you draw a picture on your test. So now they want to know the height of the eagle's nest. Well, we know the first bottom part is 5.5, but we need to find the side of this right triangle that we've drawn based on her eye level. And we know that the eagle's nest on a cliff is 66 degrees up from where she's looking, so that we can label this angle right here 66 degrees. And we know that she's 50 feet away from the cliff, so the side of this right triangle we've drawn is 50 feet. So now we have a theta, we have the side opposite from our theta, and we have the adjacent side. So we're going to use tangent again. So tangent of theta equals opposite over adjacent. Our theta is 66, so we replace theta with 66. And we're going to put opposite as x and our adjacent as 50. So I multiply both sides by 50. And I have x is equal to 50 times tangent of 66. And I'm going to go ahead and go into my calculator and type that in to figure out what x is. So, and 50 times tangent of 66 is approximately 112.3. And then we have to remember that that's x, so that's this portion of the cliff. But then we have to add the 5.5 to get the total height of the cliff. So 112.3 plus 5.5 equals 117.8, which rounds up to 118 feet since they want it to the nearest foot. So the eagle's nest is 118 feet off the ground. Number 6, they're asking us to draw an angle given the given measure and standard position. So when we do this angle is negative. So when we do that, we know it's 0, negative 90, negative 180 degrees, and then negative 270 degrees, which would make this, again, down here, negative 360, because a full circle is 360 degrees. So we start off at 0 always, and then we're going to go up to 270, and this is our angle right here. That would be a negative 270 degree angle that I've just drawn. Now for 405, we know this is 0. When we're moving in the positive direction, 90 is up at the top, 180, 270, 360, and then so on and so forth. So we start up at 0, we go to 90, we go to 180, we go to 270, and then we hit 360, and we have to keep going to reach 405. Well, 405 is 45 degrees greater than 360, which 45 is halfway between 0 and 90, so we're going to go about halfway. And there is our 405 degree angle in standard position. So the important part here is knowing that negative you go clockwise and positive you go counterclockwise. Okay, so moving on to numbers 8 and 9. Make sure that you have the following information in your notes somewhere. You need to know these 4 equations, that r is equal to the square root of x squared plus y squared, sine of theta is y over r, cosine of theta is x over r, and tangent of theta is y over x. They give us a point on the terminal side of theta in standard position, and they want us to find the exact value of the 6 trigonomic functions for theta. Well, in order to do that, we need to find what r is. So we know r is equal to the square root of x squared plus y squared. Well, they give us the points x and y. So r equals the square root of 12 squared plus negative 5 squared. So r equals 144 plus 25. So r equals the square root of 169, which makes r equal to 13. So now that we know r is 13, we can go ahead and write sine of theta as y over r, so negative 5 over 13. Cosine of theta as x over r, so that's 12 over 13. And then tangent of theta is y over x, so that's negative 5 over 12. The other 3 functions are just these 3 flipped. So cosecant of theta is sine flipped over, so that's 13 over negative 5. Secant of theta is cosine flipped over, so that's 13 over 12. And then cotangent of theta is 12 over negative 5. Now moving on to problem 9. We've got the same equations that we're going to be using, so let's go ahead and find r. r is equal to the square root of x squared plus y squared. So r, and this is x is negative 2, y is 7. So it's negative 2 squared plus 7 squared. So r is equal to the square root of 4 plus 49. And when we figure that out, that means r is equal to the square root of 53. So let's go ahead and sine of theta, remember, is y over x. So that's, or y over r, I'm sorry. So 7 over the square root of 53. We can't have that, though, so we have to multiply, because we can't have a square root on the bottom. So we multiply the top and the bottom by the square root of 53. And when we do that, we end up with 7 times the square root of 53 over 53. Okay, and cosine of theta is x over r, so that's negative 2 over the square root of 53. So we're going to multiply the top and the bottom by the square root of 53. And that leaves us with negative 2 times the square root of 53 over 53. Now, tangent of theta is equal to y over x, so it's 7 over negative 2. Okay, I'm going to go ahead and erase this work that we've done, so we have room to write the other 6. Hopefully you've written down what r is. Or the other 3 functions, not 6. So now we're going to go ahead and flip cosecant of theta is r over y, so that's the square root of 53 over 7. And it's okay to have a radical on the top, so that's fine. We can leave that. Secant of theta, we're going to flip cosine, which is x over r, so it's going to be r over x. So that's the square root of 53 over negative 2. And then cotangent of theta is equal to x over y, so that's negative 2 over 7. Okay, so moving on, let's go ahead and convert each measure from degrees to radians or from radians to degrees. When we're converting from degrees to radians, we multiply by pi over 180. So when I'm multiplying negative 120 times pi over 180, that gives me negative 120 pi on the top and then 180 on the bottom. And we can reduce those numbers to go ahead and be negative 2 pi over 3, since 120 over 80 reduces down to 2 over 3. So when negative 120 degrees in radians is negative 2 pi over 3. Now we're going to do the same thing with 63. We take 63 and we're going to convert it into radians, so we multiply by pi over 180. And that leaves me with 63 pi over 180, and we're going to reduce that to become 7 pi over 20. So 63 degrees is 7 pi over 20 radians. Now, 12, they've given us 3 pi over 8 radians, and we need to convert it to degrees. So we take 3 pi over 8 times 180 over pi. So remember, we just flip what we're multiplying when we're converting from radians to degrees. We have 180 over pi this time instead of pi over 180. And we're going to multiply across the top, or we can cancel out those. And when I multiply 3 eighths by 180, I end up with 67.5. So 3 pi over 8 radians is 67.5 degrees. I'm going to do the same thing with negative pi over 3 radians. I'm going to multiply it by 180 over pi. And when I do that, I end up with negative 600. So negative 10 over pi, or negative 10 pi over 3 radians is equal to negative 600 degrees. Alright, using the unit circle, they want us to find the exact value of each trigonomic function. So you should have your little green sheet out, and you're going to find 210 degrees. Well, cosine is x. So at 210 degrees, the x value is negative square roots of 3 over 2. Okay, tangent at 120. So that 120, the reference angle from 120, meaning the angle from 120 up to an x-axis is 30. Oh, I'm sorry, is 60. And tangent at 60 degrees equals the square root of 3. Well, tangent at 120 has to be negative, so this is going to be negative square root of 3. Well, pi over 2 is 90 degrees, so x at 90 degrees is 0. The x value at 90 degrees is 0. And tangent at 5 pi over 4, that has a reference angle. 5 pi over 4 is the same thing as 225 degrees. So that has a reference angle of 45 degrees, and tangent at 45 degrees is equal to 1. Well, since this is in a positive tangent realm, that's going to be positive 1. Okay, now they want us to evaluate on 18 and 19 the inverse trigonomic functions, and they want us to give our answer in both radians and degrees. Well, sine inverse of the square root of 3 over 2 becomes sine times the square root of 3 over 2 equals theta. Well, and another way of asking that is, where is the y value, since sine is y, equal to the square root of 3 over 2? Well, that's at 60 degrees, and 60 degrees is equivalent to pi over 3. Okay, moving on to 19. They want to know where tangent is equal to negative 3 over 3. So that's the same thing as tan inverse of negative 3 over 3 is the same thing as tan of negative 3 over 3 equal to theta. Well, that's asking where, since tangent is y over x, where is y over x equal to negative 3 over 3? Well, that's at negative 30 degrees. And negative 30 degrees is the same thing as negative pi over 6. Okay, on 20, they tell us the driver uses a ramp when unloading supplies from his delivery truck. So we have our truck, and the ramp is 10 feet long, and it tells us the truck bed is 4 feet off the ground, and they want to know, to the nearest degree, what angle does the ramp make with the ground. So this is our theta, the angle the ramp makes with the ground. Well, they give us our hypotenuse since that's opposite the right angle, and 4 is our opposite side from our theta. So we have opposite and hypotenuse, so that's sine. We know sine is going to be evolved, so sine of theta equals opposite over hypotenuse. Well, let's fill in what they gave us. Sine of theta equals 4 over 10. We are looking for theta, and 4 over 10 is 2 over 5. So this becomes sine inverse of 2 over 5 equals theta. And when you type that in your calculator, you should get 23 point something degrees, which rounds up to 24 degrees. So theta is 24. Okay, hope this review helped you out, this review video. Let me know if you have any more questions. I'll be at school at 6:45 in the morning. Good luck studying, and I hope y'all are enjoying your weekend. Have a good one.